Okay. So in last class we discussed about the preparation methods of the phenols. One more method, from cumin. It is important one as per the entrance level of examination. Or industrially or commercially, phenol can be synthesized by using cumin. Cumin is isopropyl benzene. So this cumin treating with the air or oxygen in presence of the sunlight. Generally, any reaction can be take place in presence of sunlight, proceeding by the free radical mechanism, right? So, among of these three, addition of this oxygen free radical to these three carbon atoms, this is the carbon which is more reactive, right? So, this oxygen atom of the lone pair reactive with that given to this carbon atom and forms the so these two oxygen atom are inserted between the 3-degree carbon atom and the hydrogen atom. Then it is converting into oxygen atom having a single bond is known as what number? Peroxide. So it can form the cumene peroxide, right? Which is on hydrolysis or on acidification. Then it is converting into phenol plus acetone. So commercially phenol can be synthesized or industrially phenol can be synthesized from the cumene. Cumene, an oxidation with the oxygen in presence of the sunlight and followed by hydrolysis can form the phenol. Look at the mechanism. Of course, it is not required, but look the reaction how it is proceed. It is what the cumene. So if it is then it is converting into cumene peroxide. Okay. Now we are using a solution, so it produces the H plus ion because this reaction can be take place in a solution. So aqueous conditions, it containing a water molecule which can produce the H plus ion. So any one of these two oxygen atom will be protonated. Then which of these two oxygen atom easily protonated and removed in the form of water molecule? If this oxygen atom get protonated, then it is not removed in the form of the water molecule. So basically, this oxygen atom of lone pair donate to the vacant orbital of H plus ion and get protonated. Having a plus. Now it became as a water molecule so that it is easily removed in the form of H2. If it is removed in the form of H2O, then this oxygen atom acquires what charge? Positive charge. As we know, more electronegative atom with incomplete octet has a positive charge with incomplete octet, highly unstable. So the positive charge on this more electronegative atom is not possible. Immediately it will go for the shifting. Come to this carbon, two sides are methyl groups and one side is the phenyl. In the shifting atom, that is in Wagner rearrangement, which group is migrated first? First one is, that is migration aptitude is hydride ion is first, then phenyl, right? Then the 3-degree alkyl, then 2-degree, then 1-degree. Now these two are 1-degree carbons. It is phenyl. So this group migrated, that is phenyl group migrated by loss of water molecule. It undergoes Wagner rearrangement, that is 1, 2 phenyl shift takes place. Then shifting of this group, it acquires now carbon as a positive charge. That is now a 2-degree carbon carbocation with 6 alpha hydrogen atoms. Then this oxygen atom again protonated. So by giving up electrons to this H plus ion, sorry, there is a carbocation, no? So let me change. The nucleophile H2O attacks on the positive charge of carbon L carbon. Then it is acquires positive charge. Removal of this hydrogen atom, minus of H plus ion, then it is converted into OH group. Now these two oxygens are available for the protonation. If it is treating with the H plus ion, for example, if this oxygen atom get protonated, again it form water molecule removed to form as a carbocation. So that this oxygen atom of the phenyl group involved in the protonation. Donation of the electron to the H plus ion, it acquires what charge now? A positive charge. Now there is a possibility for this bond cleavage, two sides. If the bond cleavage takes place from this side, it forms phenyl carbocation. Phenyl carbocation is highly unstable. So the cleavage of the bond towards the right hand side is not possible because it forms the unstable phenyl carbocation. So that this bond go for the cleavage. It converts into phenol plus this carbon acquires the positive charge. This positive charge is resonance with this lone pair of electrons. So giving back of electrons, it will be converted into removal of H plus ion, convert into acetone. So it is what the mechanism involved in the conversion of cumene into phenol. Okay, cumene, that is isopropyl benzene, oxidation with the air or oxygen in presence of sunlight and followed by hydrolysis or acidification gives the phenol. It is a commercial or industrial method for the preparation of phenol. Okay, note down. Put a heading from cumene. Write down. Cumene mentioned in the bracket isopropyl benzene. Cumene isopropyl benzene, bracket closed. Is oxidized in presence of air to cumene hydroperoxide. Cumene hydroperoxide. It is decomposed to phenol and acetone by treating with by treating with the acid. Right, general reaction and mechanism. Note down the general reaction and mechanism. Okay. Next one is Dakin rearrangement or oxidation reaction. Hydrogen peroxide or peracid convert the aldehyde group into OH. Particularly aromatic aldehydes which contain the electron releasing group like as NH2 or OH groups. Ortho or at ortho or para position. Aromatic aldehydes treating with the H2O2 or any peracid converting into hydroxy groups. If this aromatic aldehyde having the electron releasing group like as NH2 or OH or OCH3, that is ether group at ortho position as well as the para position. If it is these groups are at meta position, then there is no rearrangement can be takes place then. That is oxidation of the reaction cannot be possible. For example, if it is a reaction like this, treating with the H2O2 in presence of a base, then this aldehyde group converting into OH. Generally, it is known as the salsylaldehyde. Orthohydroxybenzaldehyde is converting into catechol. Similarly, then this aldehyde group is also converting into OH. It gives para-aminophenol. Okay. In case if it is para-hydroxybenzaldehyde, then we may get the hydroquinone or phenol is formed. If it is a case, treating with the peracid or CO3H in presence of a base, that is peroxy acids, convert into phenol. It is catechol. It is also another method of preparation of the phenols. Not phenol, phenols means a catechol or hydroquinol or aminoquinol, aminophenol. It is a chemical property of the aromatic aldehydes also. Only aromatic aldehydes can give this reaction. One more. From toluene, that is methylbenzene. If methylbenzene treating with the air or an oxidation with the air in presence of the manganese chloride and cupric chloride, it forms phenol by the liberation of carbon dioxide gas plus H2O. Methylbenzene oxidation with the air or oxygen in the presence of manganese chloride and cupric chloride gives the phenol. Next, why it is called as the carbolic acid? Because it is obtained from the coal. So then come to the next one, from coal. On destructive distillation, coal on destructive distillation gives three none. One is coal tar, ammonical liquor, and pitch. Gives coal tar, if you remember, we can discuss in your class in your first year, that is preparation of the benzene. So come to the coal tar, and again distillation. Coal on destructive distillation can give the three parts. Similarly, coal tar on distillation can give the four fragments. One is light oil, which can be separated at 200 degrees centigrade, which contains benzene, naphthalene, and xylene, BNX, not B, BTX. Second one is nothing but the middle oil, 200 to 240 degrees centigrade. It contains phenol, cresol, naphthalene, and a nitrogen base which is called as the pyridine. So middle oil fragment contains the phenol, cresol, naphthalene, and pyridine. How do we get this one? Nothing but the first it was treating with the sulfuric acid. It is an acid, pyridine is a base. So in step 1, it forms a salt now. So it can be separated. Then come to phenol and naphthalene. In stage 2, on distillation, these three will having the different boiling points. Then come to the naphthalene and cresol can be separated. We may get the phenol. So it is what about the preparation of the extraction of the phenol from the coal tar. The coal tar middle oil segment or fragment will contain the phenol, which is obtained at 240 degree centigrade. Okay, so these all are the preparation methods of phenol. Put a heading and write down. Decene, rearrangement, or oxidation. H2O2 or per acid converts converts aldehyde to OH. This reaction this reaction given by those aldehyde aromatic aldehydes which have electron rich group NH2, OH, NH2, OH, group either ortho or para position. OH or NH2 group either ortho or para position but not at meta position. Note on these examples. Try these two methods also now. Next, properties. Generally, pure form of phenol is a colorless crystalline solid or liquids. But when exposed to light or air, it undergoes slow oxidation and gives pink color. Pure form of phenols are colorless crystalline solids or liquids, but it gives pink color when it exposed to the air or sunlight due to slow oxidation. Means when phenol exposed to the air or sunlight, it undergoes oxidation. Phenol and oxidation can give benzoquinone. This benzoquinone is easily form the intermolecular hydrogen bond with the remaining phenol molecules because it's containing of an hydrogen atom of phenol will make the intermolecular hydrogen bond. For example, it gives red color, sorry, pink color, and treating with the that is with one more mole of the phenol molecule. It is what we can call as benzoquinone. It is connecting with how many moles of phenol? 2 moles. So it is known as the phenone, which is in red color. Due to formation of benzoquinone and intermolecular hydrogen bond with the phenol, they may form the pink color due to slow oxidation or aerial oxidation. It is slightly soluble in water because this phenol can make the intermolecular hydrogen bond. Okay, phenols. Phenol, it is slightly soluble in water. The solubility is due to the intermolecular hydrogen bond with the water molecule. Same as in the alcohols also. The solubility of the phenols is also decreases with increase in the molecular mass. Solubility decreases with increase in molar mass or molecular mass. Next, melting point of this phenol, if it is in solid state, is 42 degrees centigrade. Boiling point is 182 degrees centigrade. That is 455 Kelvin. The boiling point of phenol is much more Then the aromatic, that is haloarenes and ethers having a equal molecular mass number. Again due to intermolecular hydrogen bond. The boiling point of phenol greater than haloarenes, hydrocarbons and ether due to IMH, intermolecular hydrogen bond. So it is also one type of alcohol containing group, that is hydroxy group, but it is connecting with the aromatic nature. So it can also show the properties similar to the alcohol. One is cleavage of the OH bond. Second one, cleavage of the carbon and oxygen bond. Okay, so that we will discuss in tomorrow's class. Note down these properties. Make heading properties. Write down. Pure phenols are colorless, colorless, crystalline, crystalline, solids or liquids. And turns pink color, turns pink color on exposure, on exposure to light or air, light or air. It is due to slow oxidation. It is due to slow oxidation. Write down this as it is now. Okay, that's all for today's class. We discuss chemical properties of phenol in next class.